Now we're going to check how to do the analysis of variance problems for single factor. In this project, we're going to work with what is a tensile test for concrete, and we're going to make various samples of this. This is an example of how tensile durability is tested in the concrete. Here is the data table of the different tests we did for the different mixing techniques. We want to test where the mixing technique affects in the tensile strength for the concrete. The first thing we need to do to get the Anova table is get the sum of squares. Here we can see how we start treating the data and the different formulas. The yi is the one in the red, it is sum of every row. The y double dot is the sum of all the yi's dot. First, we're gonna try and get the sum of squares of the total. For the sum of squares of the total, we're gonna use the formula connected to the blue arrow. And what we need to do is make the square of every single sample and make the summatory of that. Then, of the value you get, you subtract that by y to the square divided by n. It is important to say that the sum of squares can never be negative. Now here we did the sum of squares of the treatments, and it's really easy. You just gotta make the summatory of the y's squared, and then subtract like last time, or by the grand total to squared over n big N, which is the total number of data. For the sum of squares of error, you just simply subtract sum of squares of total minus the one of treatments. Now we're going to calculate what is the degrees of freedom. The degrees of freedom is the number of values that are in the final calculation that have the liberty to vary. And getting these degrees of freedom is actually really easy. All you gotta do is use this simple formula. The mean squared you simply get it by dividing the sum of squares over the degrees of freedom. To get your residuals, what you have to do is get the average of all the rows, in this case the mixing techniques, and you just gotta subtract the data in each data times the average, times its respective average. Once you move one row down, you subtract each data by its new average, and that's how you get the residuals. Making this test is actually really easy. Once you get the residuals, you just gotta put them in order from 1 to the total amount of residuals you have. Then you you use the probability formula to get the y-axis. The x-axis will be the value of the residuals. It is important to note that we're looking for a straight line or a slope in normality chart to look for stop variance. Now we're gonna do the downcast test. To do the downcast test, the first thing we gotta do is get the standard error. The standard error is got by getting the standard deviation from all the data. In this case, all the samples of tension with all the mixing techniques. So once you get that standard deviation, you divide it by the total number of data, the big N in this case, and you divide. Now what you gotta do is order the averages you got from all the data in the rows above and give them an order from greater to lowest. Now what you want to do is get the minimum significant range, and you get this by multiplying the standard error times the r r value, which you get in the Duncan's table. The r in this case is for alpha 0.05. You use the degrees of freedom of the error, and you use the kind of samples you have, but you how many, but you get rid of number one. The next thing you want to do to prove it's different, the same, you know, is to get the difference versus the reference. The reference is the value you got from the minimum significant range, ordered from greater to lowest, and you have to compare it against its difference in values of average. Like in the first case, you subtract y minus y2, it's the average and that we have got before. And if the difference is greater than the reference, it will mean that it's a very different value.